So in this video I'm gonna talk about the gradient operator. Just trying to clear a very big confusion I always had regarding the gradient operator. I guess it's not that common to have this confusion, but since I had it, I'm gonna make a video of it and upload it. So if it helps anybody later. So all of us who have studied gradient operator, we have read this point, right? Gradient operator when done on a function, say x and y, we're gonna get at every point a vector that's gonna point to the nearest local maxima, and the magnitude will be equal to the slope value at that point. I think I misquote maxima. So this is a function, this is a surface plot of a function that depends on x and y. I got it from Google. So here the z value depends on x and y. So let me take a constant value of y. Say I take 0.4, and I just want to see the how z varies against x. So I took this part of the surface plot and I plotted it over here, as you can see. So it might not be that 100% accurate, but you kind of get the gist. It's just for understanding, so it doesn't have to be accurate. So well, why I had this confusion, like why I couldn't understand this part, is because in how we are taught slopes of a curve, we get positive slopes and negative slopes. Like for this curve, if I try to find out the slopes on this side will be positive, 0 at the center because that's the maximum point, and here the slope will be negative. Okay, so I used to think that since the slopes will be negative, it is not pointing to the local maxima, rather it is pointing to the minima. That's where all the confusion started, but that is not the case, because there's a difference. The slope we all talked about till now, before we learn gradient, the slope we talk about is a scalar slope. It doesn't have a direction, it's not a vector. But as you see, this is just doing the gradient of this function f of xy. This is a nebula operator, so the output is a vector. Here ax hat represents the unit vector again across x, along x, and a y hat represents the unit vector along y. So the result would be vector. So for this curve, ay will be 0, this part will be 0 since we are taking a constant value of y. So now if we are doing this one, this curve, let me draw the slopes over here. And this dot means in 0 slope. Okay, small, very small over here, a bit larger, and small again. So yeah, that's how the slope works. You cannot understand this. It's an arrow. Okay, it's just an arrow. So here the slope is positive, right? The magnitude of the vector is positive over here and negative over here. So what do you know about negative vectors? What are negative vectors? Say I have a vector A. Okay, what's negative A? Negative A is I just had to transform it, shift it 180 degrees, and this new vector will be the negative A vector. So a negative sign in case of vectors just change the direction by flipping it 180 degree, right? So if I take this negative sign and I make it positive, what would the change be over here? The arrows that you see going down all shift towards the local maxima with a positive slope. So yeah, that's basically it. And that is why, since we are using vectors and since vectors obey this property, so all the points in the curve after taking gradient is going to point to the local maximum. So this statement is justified. I hope this helped at least one person, because it always used to bother me. I could never understand why it actually worked. Yeah, that's it. Thank you for watching.